today's class, as we are still looking at the redox reaction. In redox reaction, we have been able to define what is meant by oxidation and reduction, which we have the definitions here as the addition of oxygen, while reduction is removal of oxygen. We have been able to let you know that the oxidation and reaction process, they are two opposite kind of reaction which then eventually complement one another. There is no forms of reaction where you are going to have oxidation process taking place where there will not be a reduction process taking place. They always take place together in a kind of reaction. Now, we said that oxidation is addition of oxygen, reduction is removal of oxygen. We also say that oxidation is the addition of electronegative element, and we say that reduction is removal of electronegative element. Let's now we have other definitions of oxidation and reduction as we have it here. Let's now look at how oxidation can take effect in the addition of electronegative element and removal, or reduction being called the removal of electronegative element. You have to understand these terms now. What is meant by electronegative element? Electronegative element is a form of element that gains electron. Electronegative element tends to gain electron, while electropositive element will tend to lose electron. How does that mean? How do I mean by this? And what I'm saying, you are going to see that very shortly as I'm going to give you a few examples, and I'll do the analysis of how we arrive at that particular definition. It's going to be very easy as you be with me here. Now, let's look at this number one example. We have sodium reacting with chlorine. We have NaCl2. It's on the 2 chlorine can react with sodium. Now, I want to now show you the kind of reaction that can give us an insight into what is meant by oxidation is the addition of electronegative element, and reduction is a removal of electronegative element. Now let's look at what happened there. I'm going to have you this kind of question now. We have this Na. This is sodium reacting with chlorine. The 2 chloride will react with sodium to give us NaCl. That is, you can see the equation is yet to be balanced now. So if I put 2 here, the equation is now balanced. 2 atoms of sodium reacting with 1 mole of chlorine to give us a sodium chloride compound here. Now, so look at this reaction very well. You discover that you cannot make use of oxidation is the addition of oxygen and reduction is the removal of oxygen in this kind of reaction. But we have to look at it from the angle of which one is electronegative element, which one is electropositive element. Now, looking at this very well now, you will discover that this is an electronegative element because chlorine is having in compound state, chlorine ion was like this. The oxidation number of this chlorine ion is -1. So we have it to be, so this is going to be from here now. Now this sodium is able to what? There's addition of electronegative element to that sodium. So we call this one oxidation reaction. And chlorine has been given to sodium. So this is called reduction. That is removal of electronegative element. That is for that. Now here we can now refer to this as this is going to be our reducing agent. This is our oxidizing agent. In case you are given this. Now another thing to take note of this is that don't forget the other time I mentioned for you. I said that oxidation electronegative element tends to gain electron, while electropositive element tends to lose electron. So let's look at it from that angle now. Now you will discover that, now taking a look at this sodium here. The oxidation number of this sodium here is going to be equal to 0. The oxidation number of this chlorine here, because it is not combining with anything, sodium is 0. If we have an atom standing alone, the oxidation number will be equal to 0 if they are not combining with any other element. The oxidation number of this chlorine 2 is going to be equal to 0. Now, getting here, the oxidation number of sodium here will be, when we have Na, for you to have a compound, it means that they have been able, you don't forget that when we add the oxidation number together, they must be equal to 0, which means +1 minus 1. That is how the oxidation number must be. That is why they are able to have what is called NaCl. There's no compound that is formed without them being able to add to one another and be able to give us the oxidation number will be able to give us 0. If you have any compound rating, all of them, when you add up the oxidation number of them, they must be equal to 0. So we are having here, oxidation number of sodium is Na will be equal to +1, while Cl, chlorine, is equal to -1. Now, taking a look at it from here, this is 0 here. When you get here, it becomes, this is electropositive element, this is here, it becomes what? +1. That is what? It has gained electron. Don't forget that I say electronic element tends to gain electron, while electropositive element tend to lose. This one has lost electron, then it increases, the oxidation number increases. It has lost an electron. When you have a compound put, or when you have different element put into a solution, by the time they go into the solution, electropositive element will migrate towards the negative end, loses electron, and increases oxidation number. Then also for the chlorine, you can see chlorine, it gains an electron and it becomes what? Its oxidation number becomes lesser. That is what is there. Its oxidation number will be lower compared to the previous oxidation number from the reactant. It will gain an electron, negative element will gain an electron, and the oxidation number will become reduced. While electropositive element will lose an electron, and its oxidation number will become what? Increase. I hope you have been able to get that. Very good. Now, let's now look at another good example. Let's now look at another forms of reaction that will give us a very clearer view of how we can see oxidation being referred to as addition of electronegative element, and reduction being referred to as the removal of electronegative element. Now let's look at this reaction between H2S plus bromine will give us HBr, hydrogen bromine plus sulfur. So which is going to be 2, yes. So hydrogen is 2, that's 2 here. Bromine is 2, it's 2 here. Sulfur is 1 here, is 1 here. So the reaction equation is balanced here. Now, the next thing we need to note here is this. We can see that we have 2 electronegative elements, bromine and sulfur. Now, the 2 of them, we have to make sure that we have idea about their position on the electrochemical series table. The one that is more electronegative will be the one that refers to as the oxidizing agent. Will be the one that will be referred to as the oxidizing agent. In that sense, bromine is more electronegative. It refers to as oxidizing agent. Now, from here, you can see that this is it. So when oxidizing agent occur here, the reaction will be reduction. And we have this, which is the oxidation reaction. This is reducing agent. So you have to take note of it. It's very, very important when you have this kind of a case. You look at it from what we do here, see the kind of reaction, You can as well calculate the oxidation number, and then you'll be able to simplify some of this question with ease. Thanks for taking part of this class. See you soon.